So I think last time we looked at the cobweb theory, and I think we looked at the cardinal utility. I think we had done that. So, and I think we looked at, maybe you can remind me where we stopped exactly. Which calculations? Okay, let me start from there, from the cardinal utility approach. So we looked at the diminishing marginal utility. We looked at the utility of the consumer. I mean the equilibrium of the consumer when he's faced with only one commodity, X. So we said that the equilibrium is where the marginal utility is equal to X. And I think we looked at the water demand paradox. Did we look at the water demand paradox? Can someone answer in the chat? Because I don't want to take you backwards. So if we looked at the water demand paradox, then I think now we can look at the ordinal utility approach. So let's look at the ordinal utility approach. Remember, we said that the consumer has a problem of knowing how to compare commodities. We have two schools of thought where we have the cardinal and the ordinal approaches. So we say that the cardinal is where the consumer can measure the exact satisfaction he gets out of a commodity. Now we want to look at the ordinal utility approach. Ordinal means that the consumer utility is ordinal. So basically, utility is ordinal, meaning that the consumer cannot know the exact satisfaction he derives from a commodity, but he can rank commodities according to satisfaction. So under the ordinal utility approach, there are two approaches. We have the indifference curve approach and the revealed preference approach. So we shall start with the indifference curve approach. So we need to know what an indifference curve is, which I know you know because you've done this. The consumer gets the same satisfaction. So it is a locus of commodity combinations which give the consumer the same level of utility. When we have a collection of indifference curves, we call that an indifference map. So basically, with an indifference curve, that means the indifference curve above the other, above and to the right of the other, gives the consumer a higher level of satisfaction. And if it is below one, then it gives a lower satisfaction. Now, the slope of the indifference curve is called the marginal rate of substitution. That is the rate at which the consumer substitutes commodity X for Y. In other words, it is the marginal utility of X over the marginal utility of Y. Or it is the change in Y over the change in X. Because the consumer is showing how he's giving up one commodity for another. If I can draw a small diagram here so that we can see that. So we have the y-axis and the x-axis. Now, when the individual moves downwards along the indifference curve, so here, he is consuming more of Y and less of X. Now, if he moves downwards, then he's giving up the consumption of one commodity and increasing the consumption of the other. So basically, that's why we are saying that the slope of the indifference curve shows the change in y over the change in x, or which is the magnitude of x over the magnitude of y. We know that magnitude of x is the change in utility due to the change in the contour of x. That's why we are saying du dx. And magnitude of y is du dy. So basically, that is how we come up with the marginal rate of substitution being dy dx. So, and it is negative. We shall come back to that later on. So we want to look at, when it is negative, it means that it is diminishing. Now let's first look at it mathematically. No, I prefer to look at it graphically, so that so maybe I can use this small diagram here. Let me hope it will help. Can you see my diagram? Okay. So basically what happens is that at that level here, the consumer has more of y and less of x, because this axis, the horizontal axis is x and the vertical axis is y. So assuming the individual is here, he has more of y and he has less of x. I'm trying to explain the diminishing marginal rate of substitution. So obviously, that means y is the abundant commodity and x is the scarce commodity because he's consuming less units of x. Now, because y is abundant, then any rational consumer would be willing to give up more of the abundant commodity y in exchange for an extra unit x. So basically what happens is that we assume that at that point, he's consuming, let's say, 1 unit of x. Now, because y is abundant, so when he moves downwards, it means that he's substituting x for y. So let's say if we okay. So if he moves from that point to that point, you can see he's giving up more of y because y is abundant. So if it is abundant, that's why he's giving up more of y to get an extra unit of. Obviously, when he continues, now as he continues downwards, it means that x becomes now abundant. Oh. So okay. So when you look at the diagram, you can see that now as he moves further downwards, he's giving up less of y because now y is becoming scarce. And now he's willing to give up less of that commodity because it is now becoming scarce and x is becoming abundant. So you can see at first he's willing to give up more of y, then he reduces and it will reduce further. So that's what we call diminishing marginal rate of substitution. The slope of the indifference curve is diminishing. So basically that is the graphical part of explanation for it. So the mathematical is we need a utility function. So if we have this utility function where we are saying that utility is a function of x and y, and so the marginal utilities of x and y are du dx and du dy. So first of all, we assume that only commodity x is changing and y is held fixed. So if it is only commodity x changing, obviously the change in utility will be due to a change in the commodity of x. So this is given by that. So we are looking at that means utility will change by du dx times the change in x. The same applies to y. If it is y changing by small amounts, this triangle means change in x. So if y is changing by small amounts and x is fixed, then the same equation, but now this time it will be du dy times change in y. And now if both are changing, then it means that the change in utility will be given by that sum, du dx times change in x plus du dy times change in y. So now, how do we move from there? Now, since change in utility, now we want to show that the marginal rate of substitution is diminishing. So first of all, what we have to do, we want to equate this change to 0. When we say that change in utility is equal to 0, obviously it means that the utility is constant. And we know that along the indifference curve, utility is constant. That's why we are equating that the change in utility to 0, because along the indifference curve, utility is constant. Prosper, ask.
Doctor, please, do you please help us and first repeat on the changes in utilities?
Okay.
Yeah, I've not understood. Like, could you please maybe start over just on those utilities, the changes?
Okay. Okay, so let me go back a bit on that. So we assume like we have the marginal utilities, but if let's say one commodity changes by small amounts, that is the change in x. This change, triangle x means change in x. So that is the change in the x by small amounts. Then we assume that utility, of course, utility changes. We assume that utility will change when the amount you consume more or less, whatever. So we assume that y is held fixed. So the change in utility will be equivalent to that. That is the marginal utility of x times the change in x. So that will give us, this du dx is the marginal utility of x and the change in x. Likewise, if it is commodity y changing and x is held fixed, then the change in utility will be given by marginal utility of y times the change in y. So this is what we have here. So you can just say marginal utility of x, then times marginal utility y. So, sorry, not marginal utility y, times the change in x. Sometimes now these require I'm trying to write that equation for you so that you, but I have to go to the insert and look for the symbol and whatever so that you understand. So if you see I'm pausing, it is because I'm trying to put, and I can't see the symbol I'm looking for. Okay. Basically, what I was trying to do was to write here, but when I go in the equation thing, then I'm obstructing you because you cannot see that on the screen, the equation. When you write it manually, then you have to look for these symbols. So basically, let me just explain for now. So this is magnitude of x times change in x plus magnitude of y times change in y. So of course, this is assuming that both commodities are changing. So that means the utility will change by that. Now, what we are trying to do here is to show that the slope of the indifference curve, that is the marginal rate of substitution, is diminishing. So first of all, what we do, we equate the change in utility to 0, because along the indifference curve, the utility is constant. So that's why the change in utility is equal to 0. So we equate this whole equation to 0, like I've done here. Okay. Of course, from this, maybe we cannot proceed much because we don't have the exact utility function. That's why from here, I go ahead and use a particular utility function. Now, suppose the utility function is x times y, that is xy. Now we want to show that the marginal rate of substitution is diminishing. So we are going to use this. So if we have x and y, I mean x times y, what is the marginal utility of x? It will be y. Of course, now this is where the online lecture bores me, because I cannot ask you to tell me. Okay, so now the marginal utility of x is y. So we have y dx. And the marginal utility of y here is x. So we have x dy, like here. So this equation here, we say x dy plus y dx from our example of utility function. So when you take one the other side, you have that eventually you have dy dx is equal to negative y over x. So dy dx is the marginal rate of substitution, and this negative here shows that it is diminishing. So basically, that's how we show that the marginal rate of substitution is diminishing. In your free time, you can try out these other utility functions. At least I've worked out that of xy, and I think even x squared, y squared, I've worked it out here. You can also try for this last one and see, like show that the marginal rate, you practice, even if I've given it to you, you go ahead and see how we show that it is negative, because obviously when I bring in the test or exam, I'll not bring these particular utility functions. I can give other utility functions. So you have to familiarize yourself with that. Let me hope that is now clear. Now let's go to the assumptions of the ordinal utility approach. Now, of course, we assume two commodities, X and Y, and their prices are known and given. Consumers' taste habits and income remain constant. Utility is ordinal, where we said that the consumer cannot measure the utility. So it is ordinal, you can just rank. There is non-satiety or greed. It means that the consumer always prefers more to less. And then the consumer is assumed to be consistent and transitive. Consistency is that if he prefers combination A to B, it means that he cannot prefer B to A in another situation where both combinations are present or are available. And then transitivity is the three-way consistency, where if he prefers A to B and prefers B to C, then he prefers A to C. That is the transitivity. Then the theory assumes diminishing marginal rate of substitution, which we have looked at. Now, the properties of indifference curves. I've told you of the indifference map. So the first property that an indifference curve which lies above and to the right of the other represents a higher level of satisfaction. By the way, you have to remember these properties because they are used in other analysis, like when we go to the substitution effect, when we go to the application of indifference curves, we need to know these properties. So you need to understand them. So we are saying that an indifference curve which lies above and to the right of the other represents a higher level of satisfaction. So obviously, any rational consumer would prefer a higher level of satisfaction or a higher indifference curve. The slope of the indifference curve is negative. We have looked at that, the negative MRS. Indifference curves do not intersect. and transitivity assumptions, because when they cross each other, then there will be, of course, there will not, this consistency will not be there. There will be a contradiction when the slopes cross each other. Indifference curves are convex to the origin, which is shown by the diminishing marginal rate of substitution, because we know that if the indifference curve is concave to the origin, if it is concave, then the marginal rate of substitution will be increasing. So basically that means so we cannot have that, because when you see, when we go back to our analysis there, you see that if originally the consumer is there and commodity Y is the abundant commodity, then he's willing to give up little of that commodity, yet it is abundant, to get an extra unit of X. So the marginal rate of substitution is increasing instead of diminishing. So now when you look at that diagram, so this is very irrational of the consumer. It would be very irrational. When Y is abundant, you are willing to give up very little in exchange for an extra unit of X. Yet when it becomes scarce, now you are willing to give up more of this commodity, yet it is becoming scarce, now in exchange for an extra unit of the abundant commodity X. So this is very irrational. So basically, indifference curves are convex to the origin. In other words, in this analysis, we accept that the marginal rate of substitution should be diminishing and it is not be increasing like here, because otherwise it loses meaning. The individual cannot be rational with this. Then indifference curves cannot touch either axis, because in the assumptions, we have already said that the individual consumes two commodities in a combination. So if the indifference curve touches the maybe the y-axis, it means that he's consuming only one commodity Y. And in this analysis, we are saying that he has to consume two commodities in combination. Then indifference curves are not necessarily parallel to each other. Of course, it is okay that indifference curves are not parallel to each other. In other words, they can have different slopes. When they are parallel to each other, it means that they have the same slopes, but it is okay if they can have different slopes. Now, we look at the budget line. This shows the alternative combinations of X and Y that the consumer can purchase with his income. So let's first look at the properties. Mathematically, it is a locus of commodity bundles, X and Y, that satisfy this. So the budget line is the price of X times the quantity of X plus the price of Y times the quantity of Y. Okay, let's assume the individual's income is, let's say, 500, okay, let's say 1,000, if that is our budget. If B is equal to 1,000, and then we know that the price of X is equal to, let's say, 200. So if he's consuming only one commodity X, then the budget is going to be equal to PX times X. Because, so basically, that means with this budget, he can consume, let's say, 5 units of X. So it is the price of X times X will give you 1,000. Now, if he's consuming two commodities, then we have this budget, that budget. Okay, so the budget line divides the entire commodity space into two, that is the attainable and the unattainable space. So assuming that is our budget line. So inside the budget line, we have the attainable set, and outside the budget line, we have the unattainable set, because the budget line indicates the income. So this is what, along the budget line, the consumer exhausts his income. And be above the budget line, these commodities, these combinations are unattainable. They are unaffordable by the individual. And you can see the slope of the budget line is negative. Of course, because of the limited budget, in the assumptions, we said that the budget is constant. So because of the limited budget, if you increase the consumption of one, you have to reduce the consumption of the other, and the budget line will have a negative slope. And this budget line depends on two elements, that is the income and the prices. When either of these change, the budget line will change. For instance, when the price of X falls, that means the consumer can buy more of X. So the budget line will rotate outwards to show that the individual can buy more of X. And obviously, if so, he will rotate outwards. If the price increases, the budget line will rotate inside. So basically, that is why we are saying that it depends on two commodities. Now, what if it is the income? If it is the income, the budget line just shifts. So if we have our original budget line, let me just give it another color. So assuming that is our original budget line, and it is the income changing. So when the income increases, let's say, this budget line will shift. So it will just shift, it will not rotate. So there will be a shift. I know I'm boring you because you did this in first year, but I cannot be sure. So that's why you have to bear with me. So basically now you see the budget line has shifted. No, that's the wrong. So the budget line is shifting from the red to the, and vice versa, anyway. So basically that is the budget line. Equilibrium position of a consumer. The consumer is in equilibrium if he maximizes utility. And there are two conditions here. Of course, graphically, this is where the budget line is tangent to the for the consumer to achieve this. This is a necessary condition. So this is where the budget line is tangent to the indifference curve, which is the necessary condition, but not sufficient. Of course, the slope of the is that indifference curves must be convex to the origin. So that is diminishing marginal rate of substitution. So sometimes when people can give you a utility function and they say that show that they are convex to the origin. And then, of course, deriving. And then what you know that convexity implies diminishing marginal rate of substitution. So someone can use that phrase just to confuse you. But you know that convexity implies diminishing marginal rate of substitution. That is the negative. So let's see how we derive it. Of course, why we say the indifference curves must be convex to the origin, if because we have already seen that. Let me see if I can see where I drew this one. Now, if we look at the point of tangents of the budget line and look at the first equation, it gives us the utility. So we are saying that utility is a function of x and y. So that means our budget is x plus py y. And like we said, we introduce in a factor, which is the Lagrangian multiplier. And we multiply it by the constraint. What now here you have to be careful. You sometimes to count the utility to be the constraint. So we will be assuming that utility is constant. But now, in the assumptions, it is the budget which is constant, which is fixed. So it is our constraint. So we multiply this lambda. Lambda is our multiplier into the constraint. But after rewriting it in that form, like you put everything on one side, of course, for simplicity. So you form a composite function Z. You remember that. And then we try to find the partial derivatives of this function with respect to the three variables x, y, and lambda. So dz dx is du dx minus lambda px. Okay, I will not bore you with this because we went through that. So here we have, in the utility function, we have x and y. So we are differentiating with respect to x. So we say du dx. When we go to this side, we have lambda px because pyy and b would be 0. So we equate to that 0. dz dy equals that. We equate it to 0. Then dz d lambda. Of course, here in the utility function, there's no lambda, so it is a 0. We go this side, and we have b minus pxx minus pyy equal to 0. So we have three equations now we are interested in. Equation, this first differentiation, partial derivative, is equation 1. And equation 3. So these are the, if you look at this equation 1, it becomes du dx minus lambda px. And then from equation 2, du dy is equal to lambda py. Okay? du dy is equal to lambda py. So you have that. Of course, you will ignore this one because this is for here is to find the ordinal equilibrium. So what we do here, we need to get rid of the lambda. Because in this ordinal approach, we don't assume constant marginal utility of money. And in the cardinal, we said that lambda is the marginal utility of money, which is constant. That's why we maintained the lambda in the cardinal utility approach. So this one is for the cardinal. Now for ordinal, we go for this one. Like in other words, when you have marginal utility of x equal to lambda px, and marginal utility of y is equal to lambda py, you divide these two to get rid of the lambda here. And then you have this equilibrium. Marginal utility of x over marginal utility of y we equal to px over py, and that is the marginal rate of substitution. So that is the equilibrium. Samba, ask. Samba, I don't hear you, Samba.
Yes, madam, I just request for your repeat of the order process.
Samba, you cannot say all the process. Okay, you first tell me what you understood. Because if the process, it shows me that you have just signed in and you want me to repeat myself. Okay, you explain. And I see where I be stuck.
Madam,
From where?
I'm stuck from the right.
From the what?
The right.
The right?
Yeah.
Which right? Okay, you ask
From
the
the
question
formula
properly.
of b minus px.
Samba, you have not been around, or maybe. Okay, let me repeat that. Let me repeat. Okay. I think you start from here. Now, this, do you get that? So you have two functions. You have the utility function, and you look at the two, and you have to decide which one of the two is the constraint. Now, in this case, the budget is the constraint, because in the assumptions, we said that the budget is fixed. Whatever is given as fixed is the constraint. Do you get that? So what you do, you introduce in the Lagrangian multiplier, which we multiply by that constraint after rewriting it on one side. And then you multiply it by lambda. So basically, that's what we are doing. Composite function. But the composite function is you add this utility function to the buyer. So this is our composite function. I call it Z, anything you want. I've called it Z, the composite function, it is Z. So after getting the composite function, now maximization, we are trying to maximize. So maximization is achieved partial derivatives. Now we have three variables here. We have x, y, and lambda, which is the multiplier. So we want to find the partial derivatives of z with respect to those three variables and set them to 0. So we start with x and say we say dz dx. So when you go to the utility here, it says du dx, because of course the utility is a function of x and y. So there is x. So you say du dx. In other words, the change in utility due to the change in x. And then when you go this side, b is a 0, so we ignore it, and pyy is a 0 because there's no x in pyy. So we consider this one pxx, and then we differentiate, and it gives us px. By the way, I imagine you know how to differentiate, how we get px, okay? I told you the other time how we look at the power of the variable with which we want to differentiate. So x is the power 1. When you multiply into 1, you have 1 pxx, then you subtract 1 from the power. which gives you a 0. That's why the x disappears, because a number to the power 0 will give you 1. So that's why we have lambda px, and you equate it to 0. You do the same for y and lambda. So you see with lambda, decide the lambda, in the utility function, there's no lambda, so that it is a 0. So we go this side and we differentiate that with this now this one will be lambda b, lambda pxx, lambda pyy. So eventually when you differentiate, you remain with that. Hope now that is clear. So we are interested in these 3 equations. So first of all, we use the 2 equations to get the equilibrium. Du dx is equal to lambda px, and du dy is equal to lambda py. When you divide the 2, you get this, because du dx is the magnitude of x, and du dy is the magnitude of y. You divide these 2 equations here to get rid of the lambda, and then you get the equilibrium. Samba, let me hope that is clear now. So basically, that is that. Now, yes, Sharon.
Good morning, madam.
Morning.
I would like to find out when you are talking about how to prove convexity, you talked about like why concavity is not possible. So do we prove by contradiction? By
No,
saying...
it depends. It depends. It depends, because I said that if it is mathematically, if you are given a utility function and you are told to show whether it is convex, then you have to show that the marginal rate of substitution is negative. Mathematically, I showed you how to do that. If it is by diagram, that's why I also explained using the diagram. So basically, it depends on the question. But what I wanted to say is that convexity means diminishing marginal rate of substitution. So I can tell you to show it graphically why it should be diminishing, or what it implies by diminishing. I can tell you to show graphically, or I can give you a utility function and then you show mathematically how the marginal rate of substitution, whether the marginal rate of substitution is diminishing. Joseph. Joseph, are you asking? Unmute yourself and ask. Okay, maybe he just put up the hand. Okay, so basically that is the equilibrium. Now, most of the questions would come from here. Like for instance, someone can ask, find the quantities of x and y consumed in equilibrium, or the optimal quantities of x and y. So we use those equations, okay? So basically, we derive the optimal. Let me first finish before I answer any more question. Otherwise, I will not finish what I want to cover. So let me finish up to the end. Now, you are given a utility function, and you are required to derive the optimum quantities of x and y. How do you go about this? So if we call this final equation, equation 4. So we said, remember I said this is equation 1, equation 2, and equation 3. Now, assuming now this final one is equation 4. Now, the other question about the optimum quantities of x and y requires us to use equations 4 and 3 here. So now that is what we are going to show. We are using equations 3 and 4. Now, let me do that. Let me add a slide so that we can go through it and see how we can do it. Okay, so let's use a particular utility function. assuming utility okay, utility is equal to xy. That is our utility function. And so that means we have the equation marginal utility of x equals, okay, marginal utility of x. Now you bear with me. I'm going to put the equation and then later you'll see it. I don't think you can see when I'm putting the equation because I want to go slowly on this. So yeah, what I'm trying to do is to write the marginal utility, that equation, so that it is understood. Marginal utility of x over okay, that's what I was putting. Marginal utility of x over marginal utility of y will equal to px over py. That is the equilibrium. That is our equation 4. You remember our equation 4. This is the equation 4, okay? So we are saying that we want to find the optimum quantities of x and y consumed in equilibrium. So what we do here, we look at equation 4, and from this, when we go back to the first one, so we want to reach to this equation. We know that the marginal utility of x, of course, you can go through the whole process, but I'll just say, so we know that the marginal utility of x is so let me also, so we are talking. So now we have that y over x, because marginal utility of x from this utility function is y, and the marginal utility of y is x. So we have y over x equal to px over py. This is our equation 4. Hope that is clear. Now what we do here, we just want to manipulate this equation 3, I mean equation 4, into our equation 3 here, the lambda, the dz lambda equation. But of course, to substitute, we need to play around with this equation. So what we do, we cross multiply so that eventually we have pxx when you cross multiply y. So you have that. After cross multiplying this, now you have this. So you take this as your equation 4. So you can see we can easily substitute this in our equation 3. Let me also write equation 3 so that we can know. I'm trying to write equation 3, which is b minus this is our equation 3. The dz d lambda is that. So we want to substitute this equation 4 into that. And we are saying pxx is equal to pyy. So we can rewrite this in such a way, let me write that. So it is so you see, now I've written B minus PXX minus PX. Now I've got rid of PYY. Since PYY is equal to PXX, so I'm substituting this in our equation 3 so that I have now 2 PXs like this. Hope it is clear to everyone. So that this is the same as that. Now after substituting this, you can do the same for Y. Let me also write, because if you want to find the commodity, the quantity of Y, you also need to substitute in Y. So you see, now I've done for both. So you can either do B minus PXX minus PXX, or you can say B minus PYY minus PYY. Okay, so when you use this, let's first use that. Now this one will give us B minus 2PXX. Let me put it in another equation. So basically, from this equation here, we have B minus 2PXX. Okay, so when we take it the other side, we have B is equal to 2PXX. And of course, this is, I made a mistake here. It is not Y, it is X. So basically, X is equal to B over 2PX. So now this equation here gives us the quantity of X consumed in equilibrium, this equation. In other words, if you are given information about the income of the individual and the price of X, you can know the quantity of X. Let's assume that the income, our B is equal to, let's say 500. And then the price of X is equal to 20. So you can know the quantity of X consumed in equilibrium. And likewise, that of Y is B over 2PY, B over 2PY. So that of Y looks like that. Y is equal to B over 2PY. So this will give you the quantities here, the quantities consumed in equilibrium. There are also the demand functions. This also derive, the question may be derive the demand function for X and Y. So the same equations here are the demand functions, which we call the Marshallian demand functions. Of course, the name is from the person, Marshall. So he came up with these ideas. So if they ask you, because the question may not be derive the optimum quantities of X and Y, but it would be, maybe it would be derive the Marshallian demand curve functions for X and Y. Still the same functions will give you the demand functions. But now, if you are given information about the income and the price of X, and you are told to ask to find the demand function. Okay, before we go to that, so now that means the quantity of X consumed in equilibrium will be what? Who can do the simple mathematics? So basically that means the quantity of X will be 25. Let me hope I'm right. So X will be 25, the optimum quantity. So that means X will equal to, hopefully, if I'm wrong, you correct me. So that is the quantity of X consumed in equilibrium. Now, if you are told, you are asked to find the demand function. Now, don't give 25 as the demand function. The function should remain a function. Probably you can say that the demand function is B over probably you can write it as this. It is in a function form. You leave it in a function form. So you don't substitute everything. So that is a function. If you give 25, that is an amount. So it is a quantity. So you have to be careful when you are doing that. And then, of course, the demand curve is it has a negative slope. How do we show the slope, the negative slope? So you get this demand function and you differentiate it with respect to Px, because we know that the demand curve shows the relationship between the quantity demanded and the price. Now you want to see how the quantity changes when the price changes. So that's why we differentiate with respect to price of X. So we say dx dpx. Of course, this one should not confuse you. I'm just trying to turn the fraction into a normal figure, because there it is easily differentiated for when it confuses people. So this is the same as that. But I'm trying to differentiate with respect to the price of X. So we look at the power of Px. So it is negative. So we multiply the function into -1, which becomes B into 2Px. Now you subtract 1 and you get -2. That's why it goes back down. When it goes back down, it becomes a positive. So now this negative sign just shows that the slope of the demand curve is negative. So this is just to show that. Okay, now I can welcome some questions, maybe before we continue. If you have a question, you put up your hand, you raise the hand. Okay, no question. Is that okay to everyone? Okay, let me see this one. Emma, unmute yourself and ask.
Doctor, how about if they ask you for the utility functions?
No, we haven't covered that. Okay. We have just covered for the quantities, whatever. So when you say they ask for the utility functions, maybe you ask the question, I don't know what kind of question is that. The question comes how? Because this is what I know from this, this is what I can ask, either to derive the optimum quantities or the optimum utility. Even if I say the optimum utility, not a function. I know what you are trying to ask, but for now, this is what we are covering. Because you can go further in indirect utility functions and whatever, but now we are looking at this. So here, the other question we can ask is what is the optimum utility? Still you use the same function, but then if you know X, you know the optimum count of X and the optimum count of Y, then you can know the optimum utility. You go ahead and substitute it into the utility function, which is X times Y. Okay, so basically for now, those are the questions. If we come to utility functions, then we can see what happens. But for now, we can get 3 questions from here, either the demand function or the optimum quantities of X or the optimum utility. Prosper, unmute yourself and ask.
Doctor, I was asking, now when you're answering the question on that Y and X, do I just write Y over X is equal to price of X over price of Y? Oh, I have to show that I differentiate. Oh, and then maybe another thing, when you're finding...
First answer that one, because I will forget.
Okay.
So it is okay. It depends, okay? Now, if it is this, you know, for you in an examination, what you do, don't limit yourself. You go through the whole process because you don't know the marking guide. Because if I see someone deriving it like the way we did here, I cannot give him the same marks as you who started from here. So you are right, but try to go through this because you never know, because I may also be looking at how I can fail people or how I can, do you guys have, then I see someone has bothered to go through the whole process up to that point where you want to start from. And then you lose marks on that and no one will complain. Because I'll say, no, I've given marks from the beginning to know that someone understands. So basically, in an exam, try not to limit yourself because you don't know the marking guide. Okay, Prosper, ask the second question.
Then I was asking about the zeros. Are we taking it? We're taking them to the like when we are deriving dz dx, dz dy. We are taking them to the optimal marginal utilities. That's why we are equating to 0 all.
No, this is now a mathematical rule. When you want to maximize, maximization in mathematics is achieved. I hope you are talking of these zeros here.
Yes, doctor.
Yeah. In mathematics, okay, of course we borrow some from mathematics. The mathematicians tell us that when you want to maximize, you have a function which you want to maximize, you get the partial derivatives of that function with respect to the variables, and you set it to 0. So that's why we are setting them to 0. Does that answer the question?
Yes, it answers. Then maybe the last question would be, could you basically, I think, explain more about the Lagrangian multiplier. Why do we introduce it on that budget function?
Still, the mathematicians tell us that the problem is solved using the Lagrangian multiplier. So you need to introduce a factor, which is the multiplier, and you multiply it into the constraint. So in this case, the constraint is the budget line. Do you get that? So basically, at this point, that's what we only want to know. That, okay, mathematicians tell us that if we pass here, we reach there. So if they tell us that, and they're the mathematicians, probably will go there and say, why do we pass? Okay, Prosper, hope that answers. Is it Namuyomba? Namuyomba?
Yes, madam. Well, my question is, like, for example, in an exam, if you're given a question to find the optimal quantities of X and Y, do you start from this side whereby marginal utility is equal out, marginal utility of X out of...
I've just answered.
Oh, maybe my network was that.
You were doing what? You were chatting in the chat.
No, I think my network was off.
Prosper can answer that question for me. Prosper, can you answer that question for me? Raise your hand so that I can unmute you. because I answered that question, Namyomba. I said that it is okay to start from here. Prosper, maybe you unmute and answer that question for me.
So Namuyomba, the doctor said that it's very good to not limit yourself during an examination, because you may find that he'll find like there is a marker location where those differentiations are important. So do not start from the marginal utilities. You derive from the Lagrangian function, then you also derive the dz, then the all those functions, so that you can. So a person who has done them is much more better than you who has studied from down there.
Okay, thank you, Prosper. So I think that answers Namyomba's question. Another question before? I don't know if we could go to another set of slides, because okay, let me. Okay, Rebecca, do you have a question? We want to go to another set of.
Yes,
I want
thank
to
you. Thank you, Doctor.
Yes.
My question is, after deriving that answer, there is a statement that you said that you do not leave the answer, but I didn't get that. That statement wasn't incomplete to me. You understand? Do we leave the answer at that point, or?
No, I was saying I was trying to differentiate a demand function and a quantity and optimal quantity. If you are required to get the optimum quantity, you can say that X is equal to 25. And yet when you are asked to find the demand function for X, you cannot give 25 as the answer, because it is not a function, it is a quantity. So you leave it in a function form, like you can say X is equal to B over 40, okay? So basically that's what I was saying. Fred. Yes, Fred?
Madam, my worry is I didn't understand where I reached this point where y out of x equal to px out of py.
I think now this is the time where you take the slides and you go through them. Because if you cannot, and I mean up to this point, now I cannot repeat that for now. So what you do, you first go through the slides. You ask me the same question if I meet you during the physical class. Yes, Trevor. Okay. Semaganda, I will answer you during the physical class. You first go through the slides. You'll understand, okay?
Okay.
Okay, I think, Semaganda, do you have another question? Okay, yes, okay. Okay, so basically, I think that's okay with that. Let me stop sharing this. And I don't know if you are fresh enough to start another topic. You know, under the cardinal utility approach, I mean you don't want to go to another topic. Let me just introduce it. I know this one needs when you are fresh. And let me hope next week we shall meet physically. Let me hope the timetable, they will open up so that we discuss these things well on the board. But when you look at the limitations of the cardinal utility approach, you read about that because you also did that in your first year. So basically, one of the limitations is that the cardinal utility approach shows that the demand curve is downward sloping because of the law of diminishing marginal utility. That is the cardinal. it ignores the substitution and income effects of a price change in the cardinal. That is one of the limitations. So under the ordinal, we want to explain these substitution and income effects of a price change. Of course, substitution from substitution, because when a price changes, like for instance, when the price of X falls, now commodity X becomes cheaper compared to commodity Y, and the individual will substitute the cheaper commodity for the expensive commodity Y. So he will reduce the consumption of commodity Y because it is expensive and increase the consumption of commodity X. That is what we call substitution effect. Income effect comes about because of the income. So we know that the income is fixed in the assumptions. But then when the price of X falls, the individual becomes better off. That means that with the same income, he can buy a larger basket of goods. So his real income has changed. The nominal income has remained constant because it is assumed constant, but because of a price, so that's what we call the income effect. And we need to describe, to explain these when you are fresh. So that's why at this point, I think we should not continue. And I think we should stop here unless if a few of you have some questions. If there are no questions, then of course I'll send, someone has raised their hand, Henry. Henry?
Madam, good morning.
Morning.
Madam, we are requesting for the slides.
Henry, is this your first time to attend?
No.
Then why are you asking that? Why are you requesting? Because that is what I always do. Simon, make sure the question is about the lecture, not about whether I'm sending notes or not. Otherwise,
excuse me, madam. And good morning.
Morning.
I wanted to ask that, like the other demand functions, the ones we are looking at, if they don't specify either a Marshallian and I just say the demand function, there is no need of doing the Marshallian one.
No, of course, the question will tell you, will show you, because of course, if it is the way I've explained it, obviously it is a Marshallian, though I may not mention the word Marshallian. The other demand curve will be the compensated demand curve, but and obviously you know what happens when you know that it is the Marshallian demand curve, okay? Hope that answers the question. If it is silent, you obviously know it is the Marshallian. Though it would also depend on what is in the assumptions, because if I assume that utility is constant, if I say that the utility is constant, I assume that you will understand, but you understand that when we come to the other compensated demand function. So obviously that means you know that obviously the moment she says utility is constant, then she cannot be referring to the Marshallian demand curve, because for the Marshallian demand curve, utility is not constant. Okay, hope that answers. But when most cases, when the question is silent, then it is the Marshallian demand curve, okay? Okay, I think this is enough for today. Thank you for listening and have a nice day.